Hello and welcome. Have you ever looked at Java code and wondered how it all stays so neat and so secure? Well, today, we're going to break down its 4 levels of access. And we'll use a really simple analogy that I promise is going to make everything just click. So, let's really think about this for a second. Picture a massive software project, right? We're talking thousands of files, maybe dozens of developers all working at once. How on earth do you control who can see what, who can change what? How do you stop one tiny mistake from bringing the whole thing crashing down? That is the exact problem that access specifiers are built to solve.
To get a real handle on this, I want you to imagine that your entire Java program is one big modern office building. Every single room, every floor is a different piece of your code. And those access specifiers we're talking about, well, they're like the security levels, the key cards and the rules that control who gets to go where.
So, are you ready for the tour? We're about to take a walk through this building and check out the 4 different security clearances or access levels that keep the whole operation running smoothly. Our first stop on the tour is right here at the entrance, the main lobby. As you can see, it's bright, it's open, it is the most accessible part of the entire building.
This lobby? That's our public access level. Absolutely anyone can walk right in. Employees from any department, visitors off the street, the delivery person, you name it. There are literally no restrictions. So in Java, when you mark something as public, it means it can be seen and used from anywhere and everywhere in your program.
So the key takeaway here is that public gives you 0 restrictions. Any class, it doesn't matter what package it's in, can see and use a public member. It's basically the welcome mat for your code. Now, that's useful, for sure, but you've got to be careful. Making everything public is kind of like leaving every single door in the building unlocked, which, as you can imagine, can lead to some big security risks and really messy code.
All right, let's head out of this busy lobby and make our way to the most secure area in the entire building, the CEO's private office.
And this represents the private access level. It is locked and only the CEO has the key. In your Java code, anything you mark as private can only, and I mean only, be accessed from inside the very same class where you declared it. It's completely off limits to everything else. A perfect real-world example, a user's password. You want that information kept strictly private to that user's own account.
And you can see just how strict this is, right? Nothing else gets in, not even child classes, which are called subclasses. This is the heart of a really important idea in programming called encapsulation. You're protecting sensitive data by hiding how a class actually works on the inside. In fact, it's considered a best practice to make your variables private unless you have a very good reason not to.
Okay, so we've seen the 2 extremes, the most wide open area and the most locked down. But what about something in the middle? Let's head over to a restricted department, one that you need a special employee keycard to get into.
This department is our protected access level. So regular employees who work together in the same group or, in Java terms, the same package, can get in. But, and this is the really important part, employees who are part of a related team, a subclass, can also get access, even if their office is on a totally different floor or in a different building.
And that right there, that gets to the main reason protected even exists, inheritance. It's specifically designed for those parent-child class relationships. It lets a child class use important features from its parent while still keeping those features hidden from the rest of the world.
We have just one last stop to make on our tour. I want you to imagine an entire floor of the building. All the teams on this floor can share information and collaborate freely with each other, but nobody from any other floor can just waltz in.
This floor represents the default access level, which some people also call package private. Now, this is the one Java uses when you don't type any access modifier at all. You don't write a special keyword for it, it just, boop, becomes the default.
So, with default access, everything is visible only to other code inside the exact same package. Any class in there can access it. But if a class is outside that package, even if it's a subclass, access is denied. It's a fantastic way to share helper methods or variables among a tight-knit group of classes without exposing them to your entire program.
Now, you've heard me say the word package a whole bunch, and it's super important for understanding protected and default access. So let's take a quick second to define what a package actually is in Java.
A package is really just a way to group related classes together, kind of like a folder on your computer. Going back to our office analogy, you can think of each package as a different floor in the building, maybe a different department, or hey, even a completely separate building on a big corporate campus. It is all about organization.
And why do we bother with this? Well, mainly to keep our code organized, especially in those huge applications.
It also helps avoid naming conflicts. For example, you could have 2 different classes, both named helper, as long as they live in different packages. And, most importantly for our tour today, it's one of the key ways we provide the very access control we've been talking about.
So, as we finish up our tour, let's just zoom out for a moment and look at the big picture. Why is it so crucial to have these different security levels in our code building?
Well, just like a real office building needs security to function safely and efficiently, our code needs these access specifiers to be strong and secure. They protect sensitive data, they stop other parts of the code from accidentally breaking things, they make our code way easier to manage, and they create the foundation for powerful tools like inheritance.
Okay, let's pull everything together into one final blueprint. Here's a quick summary of all 4 levels we've covered, just to make sure it all sticks.
Here it is, all in one handy chart. Public is the main lobby, open to everyone. Private is the CEO's office, for your eyes only. Protected is that restricted department, for employees and their related teams. And default is a single office floor, perfect for collaboration within a specific group. If you think about your code this way, choosing the right access level starts to feel really natural.
And that brings us to the end of our tour. So the next time you sit down to write a class, just ask yourself, is this a public lobby or is it the CEO's office? Now that you have the blueprint, how are you going to design your own building to be both functional and secure? Thanks so much for joining me today.